Welcome to your video on simplifying radicals. Radicals is really just another name for square roots. That's why you see that here on this first slide. All right, to start, we're going to look at the question, what is a square root? When we think about a square root, roots are really what undo exponents. The symbol that you see there is a square root symbol. It's also called a radical. You can use either word interchangeably. So what this means is that if we're undoing exponents, let's say we have 4 squared, so 4 to the second power, 4 squared, that is equal to 16. If we're going to use a root to undo that, if we want to undo a square, then we need to do a square root, and that's where we use the symbol. And the square root of 16 is 4, because it is 4 times 4, that gives us 16. Now, because 16 has a nice answer, if you will, we call that a perfect square. And so what we'd like you to do now is to list the first 20 perfect squares. You can see that we have them laid out for you. So the first one, 1 squared would be 1, 2 squared would be 4. So what we'd like you to do right now is just to press pause, and then using your calculator, look at what each of the first 20 perfect squares are. Now that you've done that, hopefully, here is the result. So you can check your work and then obviously make any fixes that need to be fixed. I would say you need to have the first 10 memorized. So 1 through 100 you should know by heart. Probably 121 and 144 as well. But then the other numbers, maybe you don't know exactly what the root is, but hopefully you recognize that it is a perfect square. So like when you see the number 225, you think, that, I know that has is a perfect square. I know it has a square root. Maybe you don't know that it's 15 off the top of your head, but at least hopefully there's something that triggers there. So in other words, be very familiar with this list. Okay, so next we're just going to work on evaluating. So just looking at some of the notation. For part A, it's just really simple here, the square root of 25. So what you want to ask yourself is what number times itself gives me 25? And if you look back at your perfect square list that you just made, it's pretty easy that it would be 5. In part B, we're not really doing anything different, although you do see that negative sign in front. Just like we've seen all year, that's just a -1. So if you wanted to put the -1 in there, you could. And then 144 was a number on our list of perfect squares. And if you typed it in your calculator, you would get 12. Now, because we have that -1 out in front, it's just like saying -1 times 12, which equals -12. Part C, you've seen the plus or minus notation before. In fact, we were just working on that with quadratic formula not too long ago. So that means we actually have 2 answers. We want the positive square root of 9, and we also want the negative square root of 9. So that notation really just drops down and is a part of our answer. And then you think about the square root of 9, and that was again on our list of perfect squares, and the square root of 9 is 3. So the answer, or answers I should say, are just plus or minus 3. Now we get to the square root of 24, and this one is a little bit different. You can think about numbers that multiply to 24, like 1 and 24, 2 and 12, 6 and 4, 3 and 8, but there isn't a set of numbers that you can multiply by themselves to get you 24. In fact, it's not on our list. So 24 is not a perfect square, which means we don't have a nice answer. We can't just evaluate it like we have been in the other ones. So what we're going to be doing and what we're going to learn next is how to use a factor tree. So we're going to go through some steps, and we call these steps for simplifying radicals, but remember, radical also just means square root, so steps for simplifying square roots. And we have 3 steps. The first step is to make a factor tree, and we will be going through an example of how to do that. Now, when you're making a factor tree, you're just looking for numbers that will multiply to the given number. You can choose any factor that you wish, but it always works well if you can use perfect squares. So if you can think back to that list that we just made. Step 2 is to circle any pairs. So let's say in your factor tree you had 2 3s. You would circle the 3s. If you had 2 5s, you would circle the 5s. After you're done circling the pairs of numbers, we're going to send the pairs outside of the radical, and the singles are going to stay in. So let's actually take a look at what this means. So under that square root that we just drew there, let's put the number 24, because that's the problem that we were just looking at that we couldn't simplify. So when we make a factor tree, underneath the number, we just start putting numbers that multiply to 24. So you could use 4 and 6. And a lot of times students ask, does it matter which numbers we start with? And the answer is no, because when you make a factor tree, you have to get all the way down to the prime factor. So you basically keep breaking up numbers until they can't break anymore. So 4 is obviously going to break down to 2 and 2. 6 is going to break down to 2 and 3. So now we're on step 2. We're going to circle the pairs. And I have a pair of 2s. As long as you have 2 of a number. And they don't have to be right next to each other like that. I could have circled any 2 of the 2s. So just like if you're going to go out on a date, you have to have someone to go with. We're going to have those pairs, and they're going to go out. They're going out of the radical. So when we have our answer, there's going to be a 2 outside. When we're done, the singles are going to stay in. So the 2 doesn't have a match, and the 3 doesn't have a match. So we just multiply them back together, and we end up with the final answer of 2 square root 6. Okay, so that's the basic process. Let's practice a few more examples. So our first number here is 75. I think most people would think of 3 and 25. And then 25 will break down to 5 and 5. We circle our pairs. And then remember, now maybe you just want to like draw a radical symbol because you're going to have something to go out and something to stay in. So the pairs are going to go out. So the 5 goes out. And then the singles stay in. So 3 is going to stay in. Number 2, we have the square root of 18. Let's use 3 and 6. And then we can break the 6 down into 2 and 3. And again, we're just looking for any pair of numbers. So here we have a pair of 3s. And we have a single 2. So we are going to draw a radical symbol. And pairs go out. So the 3 is going to go out. And the singles are going to stay in. So the 2 stays in. All right, looking at number 3. 300, we could use 3 and 100. 100 could get broken down into 4 and 25. And then 4 could get broken down into 2 and 2. 25 could get broken down into 5 and 5. So we have some pairs here. We have a pair of 2s and a pair of 5s. So now when we do our radical, we're going to take out a 2. We're also going to take out a 5. Inside, we're left with a 3. And then because I have 2 things outside, I'm going to multiply those together. So I have 10 square root 3. Okay, a few more examples. You may notice that the ones we're looking at now have a number that's already out front. So that number is really important. We have to keep it in the problem, but it's not going to be a part of the factor tree. So we're basically just going to draw an arrow down to where we might write our answer. And it's just going to become a part of the final answer, but it's not going to be worked in right away. We approach the square root just like we did the other ones. So we're going to start breaking down 48. We could use 6 and 8. We could break down the 6 to 2 and 3. And we could break down the 8 into 2 and 4. And then the 4 could go down further into 2 and 2. And then we start looking for pairs. So we have a pair of 2s there. And we have another pair of 2s. And then I've got a single 3. So now, remember, the 3 that was already outside stays outside. So we're going to multiply everything that we bring out by 3. And I have 2 pairs of 2s, which means we have to bring out 2 2s. And then I've got a single 3, which is going to stay inside. So outside, you're going to have 3 times 2 times 2. So you're going to have 12 on the outside, and then 3 on the inside. So our answer is 12 square root 3. Number 5, we're going to approach the same way, only this time we have a negative 2 out front. So we're just going to bring that down for the end. We're going to split up 288. It's even, so let's divide by 2. If we divide 288 by 2, we would get 144. And then 144, I know 12 times 12 gives me 144. And then we could break 12 down into 2 and 6. And we start circling pairs. Oh, not just yet. I was thinking about pairs. You could, and that would be okay, but we're going to break the 6 down. So I've got 2 and 3, and then 2 and 3. So we have lots of numbers here to look at. So as long as we have pairs, we're going to be okay. So we've got a pair of 2s. We've got a pair of 3s. And we have another pair of 2s. So yeah, your papers make it a little bit messy here. So keep track of what is coming out. We had 2 2s and we had a 3. We already had that -2 that was brought down. And then the only thing that is single and not coming out is a 2. So now we have to multiply all these together. 2 times 2 times 3. So we're going to end up on the outside. We're going to have a -24. And on the inside, we've got 2. So it's -24 square root 2. All right, I'd encourage you to maybe press pause now and try number 6 on your own. We'll still go through it, but it's always good to try something on your own before you get to your practice. So number 6, again, we've got a number out in front, so that 10 is going to come down, and we're going to break up the 72. So let's use 8 and 9. The 8 we can break down into 4 and 2, and the 9 we can go 3 and 3. And then the 4 will get separated into 2 and 2. So again, we're looking for the pairs. We're going to circle the pairs. So the 2 is going to come out and join the 10. The 3 is going to come out and join the 10. And then underneath the radical, we are left with a 2. So again, we have to multiply all those things together. So we're going to end up with 60 square root 2. This concludes your video, and you can now start practicing simplifying radicals.